Alright, this video is going to cover Unit 7, which was over polynomials. So the most important thing here is to look at what operation is happening. For number 6 here, there's a plus sign in between these two binomials. So we're going to add and combine our like terms. So I've got 5a plus a negative 7a, and if I were to combine those, that would give me negative 2a. Then if I go and combine positive 3 and negative 5, I would also get negative 2. And that would be your final answer. It's as simplified as it can go. Next one, number 7. Now number 7 has a few things going on here. We first notice that we're subtracting these two big things, but we also have a term on the outside of a set of parentheses, which means we need to distribute. So I'm going to start by distributing before I subtract. Okay, so I am multiplying this out to give me 12a to the 3 plus 2 gives me 5. Then I take 3a times negative 6, and that gives me negative 18a to the third. Then I'm going to take this negative 2a, multiply it to give me negative 10. This has an exponent of 1, so negative 10a to the third, positive 6a to the second, because this is a negative and this is a negative, which makes it a positive, and then a negative 2a times a positive 5 gives me a negative 10a. Now I can go ahead and combine all my like terms. So I'm going to start with the highest degree of the fifth power. There's nothing else that has anything to the fifth power, so I'm just going to keep it as 12a to the fifth. Then I'm going to move on. I'm going to combine my a to the third powers. I've got negative 18 and negative 10. If I add those together, I will get negative 28a to the sixth power. Got to add those exponents. And there's no other a to the second, so that will stay by itself, plus 6a to the second. And lastly, the negative 10a is also by itself, so I cannot combine that either. So this right here would be your final answer. Number 6, we are multiplying. So there's kind of two different ways that you can do this. You can either use the box method or FOIL. I feel like most people use FOIL or the distributive property, so I'm going to do that first. On the second one, I will do the box method. So I'm going to start by taking this first term, 6a, and multiplying it by both terms in that second binomial. So 6a to the first power times a to the first power gives me 6a to the second power. Then I'll take 6a times it by negative 7, get negative 42a. Now we're not done. We got to take this positive 1 and multiply it by both terms. Positive 1 times a will give me plus 1a, and positive 1 times negative 7 gives me negative 7. After you get 4 terms, you should always get 4 terms when you multiply two binomials together. We can combine our like terms. In this case, we can only combine these two middle terms, and that would end up giving me negative 41a. Everything else would stay the same. And that's your final answer. Okay, on number 9, I'm going to show you the box method, if that's what you've been using. So this little 2 up here tells me that I have 2 of the group 2x minus 5. So I'm going to have 2x minus 5y times 2x minus 5y. Now you could do this exactly how we did the previous problem, where you distribute both terms, end up with 4, and then combine, or you can do it how I'm going to show you this time, using the box method. So you create a box, you put your terms on each side length, so I've got 2x and negative 5y, and since it's the same, I'm going to have the same on the other side as well, 2x, negative 5y. So you're going to find essentially the area of each box. I'm going to take 2x times 2x, and that's going to give me 4x to the second power. Then I'll take negative 5y times 2x, and that will give me negative 10xy. and I got to fill in the rest of them down below. I've got 2x times negative 5y again. That ends up giving me negative 10xy. And I have negative 5y times negative 5y, and that's going to give me a positive 25y to the second power. So as you're looking here, you can kind of see some like terms show up. My like terms are my xy's. Okay, so when I'm writing out this, I usually write it out first. So I've got 4x squared minus 10xy minus 10xy plus 25y squared. Now I can combine my like terms. I have negative 10 and negative 10 together. Those are not going to cancel out, but they're going to give me negative 20. So I'm going to have 4x squared minus 20xy plus 25y squared. And that is your final answer. This was the box method, but again, if you prefer the method that we used up in number 8, you can use that one also. Okay? All right, number 10. On your final, you're just going to be given a polynomial, and you have to identify which one it is based on the choices that you're given. But instead here, we're giving you some options of what a polynomial is, and you have to give us an example of that. So, crash course reminder, the first term, the first term tells you the degree of your polynomial, the highest degree. Okay. The second term in classifying your polynomial tells you the number of terms. Okay. So looking at the first example here, letter A, a quadratic, meaning highest degree of 2, and a binomial, meaning 2 terms. We can just give an example of this type of polynomial. So I could have x squared minus 17x. There's 2 terms, highest degree is 2. Okay, letter B, I've got a cubic trinomial. So that means highest degree of 3, trinomial means 3 terms. So we could have 4x to the third plus 3x squared minus 2x plus 10. Highest degree is 3. Oops, I put one extra term. I have 3 terms. Okay, yours could look a little different. That's okay. Actually, in fact, I challenge you to try to figure out a different one. All right, letter C. I've got a cubic, meaning highest degree 3, binomial, meaning 2 terms. So I could have 3x to the third power plus 5. Highest degree of 3, 2 terms. And lastly, a quadratic trinomial, highest degree of 2, trinomial meaning 3 terms. So I could have x squared plus 4x minus 7. Highest degree of 2, and there are 3 terms. All right. And lastly, for this unit, what is the greatest common factor of 36x to the third, y, and 27x to the fourth? So the first thing I'm going to look at is what is the biggest thing that I could take out of 36 and 27. If you're not sure, go ahead and just list out the factors. For 36, I have 1 and 36. I have 2 and 18. I have 3 and 12. I have 4 and 9. I have 6 and 6. Okay, 27. I have 1 and 27. I have 3 and 9. And that looks to be about it, right? So we look and see which one's the biggest from both. And there is, in fact, a 9 out of both of them. So the greatest common factor I can take out of 36 and 27 is 9. Then when you're looking at the variables, you're always going to choose the variable that has the lowest exponent. So I have x to the third here. I have x to the fourth here. So that means I can only take out 3 x's total from both of them, right? Now, the first term here has a y, but the second one does not. So does that mean I can take out a y from both of them if they don't both have one? No, I can't. So this would be your final answer. Okay, again, reminder, this is very similar, this section, Unit 7 on the final. So if you understand everything that is on here, you should be ready to rock and roll. The next video will be covering Unit 8 on factoring.